Alrighty, Joe.
I should apologize for how nervous I am, but I will be relying heavily on my good looks and my rockin' hot body. What we're going to be covering, first of all, with a show of hands, how many people know what a micrometer is or how to use one? Okay, well, that's awesome. As a mechanic, you need to know how to use a micrometer, or mic as we call them. So many industries, there's countless industries that do use micrometers. Mechanics are no different. You have to be able to do it accurately. It's used for things like measuring the thickness of brake rotors, pistons, cam lobes, valves. I mean, it's endless. It's a simple task, but it's important because of the precision that's involved. It's important to be able to know it inside and out and accurately be able to do it. So at the end of today, I hope you'll be able to apply this both on paper and in hands-on with a micrometer. So just to give you an example of how important it is, I used to own a shop for a lot of years, and there would be times where you would have a new guy starting out, pull in a car to do a brake inspection, and they tell you, hey, it just needs pads. We are able to reuse these rotors because they're thick enough. So I call the customer and tell them, hey, you just need brake pads. Simple brake job, won't cost a lot of money. But then when we check the brake rotors to go cut them, they're too thin. So I have to call this customer back and say, my guy didn't know what he was doing, you have to pay more money. Now, you know that doesn't go well, and already we're walking on eggshells with customers because they're always skeptical of us mechanics to begin with. So, you know, and we're not talking about honest mistakes. These type of things happen. We're talking about being able to know the subject inside and out. So, what a micrometer, there are several different kinds of micrometers. The inside, outside, depth ones. I mean, there's, again, an endless list. But they all do the same thing. They all do one thing, and we're going to cover that. And we're going to be working with one specific type. So know that there are many other kinds, styles, but if you can learn this one, you'll understand all of them. So we're just going to be working with one. The one that we're going to be working with is the most common one that us mechanics use, called an outside micrometer. Now, to get started here, you should know some of these basic terminologies. You should know some of these basic parts. Now, why that is, I don't know. I just feel like you should know it. And I'll give you an example. The thing that got you here today was a car. Now, you might not know everything about cars, but you know that thing you had to open to get into it is called a door. You know that if you want to look at your hood or look at your motor, you have to lift the hood. So there are just certain things that you should just know, because imagine trying to describe to somebody how you got in your car and not use the word door. So, you know, maybe as a backyard mechanic you can get away with not knowing some of this stuff, but you guys are professional mechanics now and you got to know this stuff. So the part I'll start with is the obvious, the horseshoe part, is the frame. Now this one's green, but most of them are black. So if it helps you on cars, the frame of the car is most often black, right? So if that helps you, the black part is the frame of the micrometer. The next two parts, this part's called this spindle. This is the part that goes in and out and comes in contact with the item that you're measuring, spindle. Now, it's connected to the thimble, so as the thimble moves, it's moving the spindle. So if that helps you remember it, because they sound so much alike and they're connected together and they move together, the spindle and the thimble. So far we've got frame, spindle, thimble. Now, I have a broken one here. So this is not how they work. This one is broken. I wanted to take it off to show you this silver part here. This is called, they call it the barrel, or another common name is sleeve. So barrel or sleeve, and it's got the markings, some of the markings we're going to be dealing with. So that's that part. So again, so far, frame, spindle, thimble, and then either barrel or sleeve, however you want to call it. This, going back to the good old, as the thimble slash spindle turn, it spins freely. You can lock that from turning. This one has a ring, so you can lock it and then it will not turn. This is so if you take a measurement, you can lock it and have it so it won't move because of how easy it moves. So again, it's an easy thing to remember. That one has an arm. Those are the two most common styles. This one has a ring, but they're both the locking mechanism. So either locking ring or locking nut, but just so you remember that it locks, and that's the name of it. And then there's two parts left. The anvil is just the stop, the other machine surface that you're going to put your item against. And then the last thing is the ratchet screw. So we're going to cover what this does, but you can hear it ratchets, so that should be easy to remember. So just to recap here: frame, spindle, thimble, barrel or sleeve, lock nut, anvil, and then the ratchet screw. So you'll hear me refer back to them often, but 7 things to remember. There are many other different components, but you don't have to remember everything about it, but just some of the main things. So a micrometer does a single thing. It has one function. It breaks up 1 inch into 1,000 pieces. So if you want to look at this as one rectangle, if you divide it up into 10 equal parts, you'd have tenths, right? If you broke it up, and if I just picked up one of these pieces, it would be 1/10, you would say. Same thing with the hundreds. If you divided it again, you'd have 100 pieces, and if you picked up one of those pieces, you'd have 1/100th of the rectangle, or of the inch, or whatever thing you're using. And the last thing is thousandths. So if you picked up one of these parts, you would have one really small part, but it would be called 1/1000ths of a rectangle of an inch, however you want to look at it. So that's the only purpose of a micrometer. It just breaks up 1 inch. All of them, that's how all of them work. So far, are there any questions? You guys follow the names of the parts, you got it down? Okay, that's a great question. He asked, do they make micrometers that divide these up even more? Okay, they do. They have micrometers that go 10,000ths of an inch, and I heard they have even more. But as mechanics, we don't typically use measurements that fine. So we are going to learn the thousandths ones, but if you learn the thousandths one, you will know how to do the 10,000ths one. So just learning this one thing inside and out will give you such a wide range of things that you're able to accomplish. So, okay, I'm sorry about why this is so slow here. So, I need to take your attention here to the board. So, we talked a little bit about how it's said and how it's written, and it's important. So, if I asked you to write the number 1, you would just write the number 1. If I asked you to write 1/10, you would do dot 1. If I asked you to write the 100th, it would be .01. And then the thousandths that we're working with is 0.001. Now, this is going to be significant, and we're going to come back to why. But the thing you should take away from this is every one of these measurements that we're going to be dealing with has to have that point and then 3 spots. It has to have all 3. Even if you have zeros at the end, you can't drop them off. And we're going to talk about why. So, 1, 1/10, 100, 1,000. Okay, and that's how you would say them, that's how you would write it. And just to give you an example about this, the power of of a micrometer, if you measured one of these pieces of paper that you had, typically an average piece of paper is 3/1000ths of an inch. So that micrometer, holding up that piece of paper, if you divided that piece of paper into 3, that's how fine this tool can measure. So, I mean, it's incredibly accurate and precise and very valuable for a mechanic. So, okay. The next thing that we got to cover is the typical scale. So, when you have a micrometer in your hand, and I will pass them out, you're going to see a typical scale, and they all look the same. Okay, so this is what it looks like: the sleeve or barrel that we talked about, and the thimble. These are all the markings that's on there. these written numbers on the sleeve break up that inch into tenths. So you remember that rectangle? You know, there was one rectangle and the first division was tenths. That's what this thing does. So you have 10 equal parts of that inch. Then in between these, if we could call this one $1 for right now, so 0 and $1, it's divided into 4 equal parts. So how you divide $1 into 4 equal parts are quarters, right? So let me give you, in the example of the tenths, let's say here's 0, 1/10, you can't say it like that with a micrometer. You have to write 0.100, because remember you have to have all 3 of the positions, because now it's not said as 1/10. Now it's 100 thousandths. So when you divide that by 4 quarters, like we talked about, you would have first 25 thousandths, 50 thousandths, and then 75 thousandths, and of course 100 thousandths. So that's why it's important that you don't leave zeros off, because if somebody's looking at this measurement and you just wrote 0.1, they assume that the tool you're using is only accurate to a tenth. So when somebody sees this, even though it's the same spot, on that micrometer, when they see it written this way, they assume that the measurement you made is accurate to those 3 spots. So that's why it's important you don't leave zeros off, and you got to have 3 numbers all the time. So anyway, each line on that sleeve, each one from 0 to all the way to 10, or 0 if you want to look at it that way again, are divided by these quarters. So 0, this first line, 25 thousandths, 50 thousandths, 75, 1, and then it starts over, all the way down. So it's as simple as that. It doesn't matter the length here. It's just 25 thousandths each between each one of these lines. Now, the thing that you got to remember, when you're making a measurement with the micrometer, the spot that you're going to look at, you have to imagine a line right here. And that line is where the thimble covers the sleeve. So you have to imagine this line here. And then this line is another line you have to kind of imagine. It's not that hard to imagine because there's actually a line there. But these 2 intersections are really important. Because when you make the measurement, that's where you're going to look. That's where the magic happens. This has to be true because I got this slide from the internet, and they can't put anything on the internet that's not true. So that's what you're going to look at when you actually go to measure something. So the important things to remember that we've covered so far is that every written number on the sleeve, every written number, is divided by 100 thousandths. 0 to 1 is 100 thousandths. 1 to 2 is 100 thousandths. Or tenths, but you can't say it that way, and you can't write it like that. So that's important. Every line on the sleeve is separated by 25 thousandths. Now, on the thimble, these lines are 1 thousandths. So when this thimble is on 0, let's just say it was on 0 right here. Let's say it moved all the way here. If you make 1 full revolution from that 0 back to 0 again, it will move to that first line, 25 thousandths. So every complete turn of this thimble is 25 thousandths. It breaks up that distance because each one of these are 1 thousandths. It breaks it up. So if you started to move it, but you didn't make it all the way to 25 thousandths, however many lines you have, that's the measurement you have. It'll make more sense as we do some of these practice ones and as you see it. But these are the things to remember. The written numbers are tenths, or the separation is 100 thousandths. Every line on the sleeve is 25 thousandths. Every line on the thimble is 1 thousandths. So every one of those are 1 thousandths. And every complete revolution is 25 thousandths. So those are some of the things you got to remember. Any questions so far? Okay, it'll start to make more sense, I hope. So if I ask you to read this, does anyone want to take a guess, besides the auto guys here, about what this would be? Okay, so let me...
341.
Okay.
341,000.
Okay, so the first thing you should do is you got to have these three, have this set up. And the first number is the first written number that you can see with the line. So the largest written number on the sleeve with its line is 3. So that goes into the first slot there. Now, the next, we talked about this line would be 25 thousandths more, right? So you can see that line, but can you see the next one? Can you see 50?
No.
So we know for sure that we're going to be somewhere between 325 and 350. Our answer has got to be between there because we could see this, but we can't see this. So where we get the last number is how many lines past this 25 is this measurement? Well, then you go to the thimble. This line is, here's 10, 15, 16 past this 25. So if you take this 16, which is on the thimble, plus this 25, 16, you get 41. So the answer is 341 thousandths is what that measurement is. Has anybody not got that? Is it confusing anybody? Okay, let's do another practice. This is a picture of an actual micrometer. So when you measure something, this is what you'll be looking at. So who wants to take a guess?
200,000.
Okay, well,
Yeah.
you can see the 1, right?
Oh.
And you start to see the 2, but you don't see the line
Yeah.
for the 2.
Yeah, that's right there.
So you got 1, you got 25, you got 50. Now, you can start to see the 75
Should be 175,000.
because how many past 75 is it? None. It's 0 past 75. So this is 175,000. 0.175. So, okay. Okay, this one is a little tricky. Who knows what this one is?
304.
It's 2 point. Okay. As I said, a micrometer breaks up 1 inch, but it doesn't just break up 0 to 1 inch. It could break up inch 7 to inch 8. It can break up 1 foot 1 inch to 1 foot 2 inch. You know, they have some that are 5 feet big that go around different things in train motors I saw and stuff like that. So you have to pay attention to what size micrometer you're using. We're using a micrometer. For example, this is what we've been working on, one that goes from 0 to 1 inch. But this one is printed on here. It goes from 3 inches to 4. So you can't measure anything smaller than 3. And it can't measure anything bigger than 4. It just measures the 1 inch between 3 and 4. So how you would know that is it's stamped on the micrometer. And when you see them on paper, it's always written. So this one would be 2 inches, right? 300, and then can you see the 25 thousandths? You can't see it. So it has to be smaller than 25, bigger than 3. How many lines past 3? It's only 4 lines past. So 2.304. 203,400. Well, okay, you know what I'm saying. Okay, any questions? Okay, so here, let's do this. Let's do this. I have 5 simple 5 simple ones, just try to, I think we need one more degree. Try to figure these out. And then we're going to go over them. How are we doing? Questions so far? All right, so here's the first one. How many people got that right? Okay. Again, 2, this is a 0 to 1 line. 200,000 plus the 25, but you can't see the 50. So it's 25 plus how many lines? Plus 15 lines. So 25 plus 15 is 40, so 240 thousandths. Okay, so here's the next one. It's a 1 to 2 mic. If it makes it simple for you, whenever you see this, you just write the smaller number in front until you get the hang of what we're doing here. But how many people got that one right? Okay, so right, here's the next one. The 2 that we talked about, 5, 25, 50, 75, and you can almost see the 6. Here's the 0, it's 1 line shy of that 6. So 2 inches, 599 thousandths. How many people got that one right? All right, so we're doing okay. All right, for 7, 3 inch, 434 thousandths. And then the last one was 4 inch, 4 to 5 mic, 898 thousandths. So, okay, I hope if you start to practice it and start to use the mic a little bit, it'll start to come, because once you learn it, it's almost impossible to forget it. But if you don't learn it, you're never going to get it. So, okay, actually using a micrometer. I'm going to hand out some mics. And I brought a couple things for you to measure. But you can measure paper, pencils, whatever you want. Sorry. I think you auto guys would be all right with that. There's some valves if you guys want. There's some gauges. So anyway, typically you're supposed to hold it with one hand. I'm not stuck on this, but if you do hold it with one hand, you're able to turn the mic and hold it with one hand so you can hold the component with the other. But I'm not stuck on that. I'm stuck on you getting the reading right and understanding that this is a precision tool, so you got to have some respect for it. We talked about that ratchet part, and I sent out all my good ones. The thimble, as you turn it, it has very fine teeth. It will smash down whatever you put in here. That ratchet will prevent you from doing that, because as it smashes down, it's going to bend the teeth in there, or the threads in there, and then the tool won't be accurate. So you have to use that ratchet to tighten down, and once you hear it click 3 times, you know it's tight enough. Another technique, once you have the component in there, is to rock the mic sometimes, because they're machine surfaces, so you want it to make sure that it's on the part correctly. And that's really it. I mean, so as far as actually measuring something, you have to get the micrometer. I think you should get a pen and paper to write down, because sometimes you have to take more than one measurement, and trying to remember these numbers are crazy, because you get it wrong so easy. So grab the mic, get a pen and paper, find the specifications. I'm going to show you a picture of specifications, but whatever component you're measuring, there's going to be a spec for it, like the brake rotors, for example. So you want to find those specifications. You want to hold the micrometer firmly in your hand while turning the ratchet clockwise, the ratchet screw. And then after the spindle comes in contact with the item being measured, gently rock the micrometer while you're tightening that ratchet screw until it clicks 3 times. So again, you're welcome to try different things there. Write down your measurements. Don't memorize them, because you're not going to get them right. And then compare the measurements to the specification. So this is an example of a specification. So right here is your front brake rotor, and right here it's written 0.843 is the minimum rotor thickness. So when you measure that rotor, if the number you get is smaller than that number, then you can condemn that rotor. You can tell the customer it's too thin. I can't, we can't reuse it. So that's what this tool and these specs combine to give you that, whether you can reuse that or not. They do have micrometers that measure in millimeters. They're really easy to use as well, but I wanted you to focus on just this. Okay, so if you get this, you'll be able to understand millimeter ones as well. Okay, you don't have to do the second page if you don't want to, but this is just to give you an idea if you get this or not. Questions so far with things that we covered? Covered the names, frame, anvil, spindle, thimble, sleeve, ratchet screw, lock nut. Sole purpose of a micrometer is a test question, but you should know that. The distance between each line on the sleeve.
Did you tell us number 3?
Of course I did, don't consider it.
Yeah, right, very beginning. Okay.
Yeah.
I missed.
The reason why this is one of the first lessons that we do when you enter auto is because all these components that you're going to be learning about and testing and condemning, a lot of them you'll have to be able to use this tool. So if you can't do this, and you can't do it accurately, how can I trust what you're telling me is right or wrong with the car? How are we doing? Does anybody need more time? No? Okay, so here's the answers, so you guys can grade yourself real quick. And then at the top of your page, just mark how many you got wrong, and I'll give you the scale. Anybody need more time? So here's the scale.
I design.
Okay, so it's important for mechanics to be able to use a micrometer, to understand it, to read it, and make accurate measurements. It's important to take care of these tools. They're really precise and accurate, and you don't want to ruin them. That's why that ratchet screw is important, and then storing them is important. Remember, the only purpose of the micrometer is to break up 1 inch into, in our case, 1,000 pieces. That's the only part of it, but it could break up any inch. You know, it doesn't have to just be 0 to 1. The simplest there can cost shops money, and thanks for putting up with it.